Identifying Network Connectivity Issues, Part 1 of 2. A large part of every enterprise desktop support technician's life is supporting network connectivity issues on behalf of your users. Therefore, in this nugget, we're going to look at some hardcore troubleshooting methodology, first leading off with determining the issue scope. This is part of the classification phase of incident troubleshooting, and it's absolutely crucial for you to master this skill if you're going to resolve network connectivity issues in an efficient manner. We'll then take a look at TCP/IP client-side configuration in Windows 7. Now the deal is this: if you're coming from XP straight to 7, you have some things to learn. Because although the basic mechanics of the TCP/IP protocol stack are largely the same, going from one operating system version to the next, the actual UI, or user interface, has changed significantly from XP to Windows 7. Those of you who have experience configuring TCP/IP in Windows Vista are in for a much easier time because you're already familiar with the majority of those tools. After we've covered basic troubleshooting and TCP/IP client-side configuration, we'll then look at testing network connectivity, and we'll review a handful of the built-in TCP/IP diagnostic and troubleshooting tools that ship with Windows 7. Determining the network scope. The title of this whiteboard comes directly from the 70-685 exam objectives, and what it means is simply this. You're faced with a user who has some kind of network connectivity issue. Maybe he or she's unable to check email, unable to log on to the domain at all, unable to access a web-based application, file share, network printer, and so on. And now you need to start with that bit of information and then work outward from there. First question we want to ask ourselves as troubleshooters is this network problem constrained to a single user, or are multiple users experiencing the same problem? Dollars to donuts if it's just one user who's having access problems connecting to a network share, then we can focus specifically on his or her workstation and his or her user account and work out from there. On the other hand, if you receive several support calls from more than one individual who are all having the same resource access problems, then we can look elsewhere, outside of concluding that the problem is on the local computers themselves, which in that case is probably a small likelihood. We'll want to go further out into the network infrastructure and take a look at what's going on, for instance, in our switch fabric, in our local area network topology, and the server itself that the users are trying to access. What you're seeing in the top half of this whiteboard is a fairly poorly done but effective network diagram that shows the path, or the network path, from the user's computer, which has, of course, a hardware network interface card, or NIC. In this example, we're using wired Ethernet 802.3. Same general idea with some modifications pertains to 802.11 wireless. We'll be covering wireless considerations in an entirely separate nugget a little bit later in the course. But for now, we can say that the user's PC has a NIC, a network interface card, with an Ethernet cable that connects that PC to a wall-mounted Ethernet drop, or Ethernet jack. This is most typical in business. And then the cable run in that office goes from behind the drop, through the wall, through plenum, whatever you're doing to route that cable, and you're terminating in maybe a per floor or per building telco closet or switch closet. The switch is going to aggregate connectivity at the user level. So if we're working outward in our troubleshooting, let's say an individual user is having connectivity problems on the LAN, we'll want to look at layer 1 stuff. By the way, you should be very familiar with the International Organization for Standardization's OSI networking model if you're going to be worth the salt doing network troubleshooting. Layer 1 stuff would be like, is the cable intact? You hopefully have a cable tester where you can test continuity in between the user's PC and the wall drop, between the wall drop and the switch terminator, the punch down block in the telco closet, and so on, in order to rule out a physical layer 1 problem there. Moving up the OSI stack to layer 2, that's the Ethernet level, do we have a green link light on both sides of this connection? That is to say, on the user's NIC as well as on the associated switch port. Maybe there's a configuration problem on the switch with that particular port that's preventing the user from accessing the rest of the network. Moving out beyond the switch, going from the user access layer down to the core, this is where you start making the transition typically from, say, 100 megabit per second Ethernet to gigabit Ethernet, because in most shops I've been in, once you get to the core level or the server room level, you have fiber optic connectivity among your connectivity devices. So we come to a core switch, or what's called a distribution switch. And in this simple example, we have a server directly connected to that core switch, as well as an uplink to a router that's taking this company to its internet service provider and offering internet connectivity for this organization. Now, at the switch or router level, we could also have additional subnets or virtual LANs meant for partitioning network traffic. You see what I'm saying? So it's important for you, in summary, to have a holistic picture of what your network looks like in terms of determining where you want to focus your effort. You might have heard of the split half troubleshooting method. And this is useful in computer programming, computer hardware and software troubleshooting, and certainly in network troubleshooting. Split half means when you're faced with a network problem in this context, if you can at least get an idea of which side of things the problem falls on, that allows you to dramatically reduce the troubleshooting area. As I started off this discussion with, if it's just a single user with a problem, we can draw our split half line at the PC side and pretty much focus our troubleshooting over here. On the other hand, if we have a feeling that it may be a difference between the back end, the distribution layer versus the server layer, we could draw our split line here and focus our troubleshooting over in the server room. Okay? Now then, getting back to specific exam objectives, there are some built-in tools introduced in Windows Vista and carried over to Windows 7, Windows Network Diagnostics, and this relies upon a Microsoft framework called the Network Diagnostic Framework, or NDF. Because this isn't a programming class, we don't need to know details of that. Bottom line is NDF is an Application Programming Interface, or API. Don't you love those TLAs, or three-letter acronyms? That allows application vendors to plug their network-aware application into network diagnostics. For instance, if we were developing a fancy new network card and developing a driver for Windows 7, we would want to access the NDF API to make sure that Windows 7 can run diagnostics on our new fancy network card driver. What's nice with network diagnostics from a DST or user's point of view is that Windows 7 makes it fairly easy to run connectivity and troubleshooting checks on your networking environment, your local networking environment. We'll take a look at this in the demo. We have the network map feature in the Network and Sharing Center control panel, as well as the diagnose and repair tool that we can apply to, say, a wired or wireless interface on the computer. Windows 7 TCP/IP client-side configuration. It used to be, in the days of Windows networking, going back many years, that there were other protocol choices besides TCP/IP. For instance, there was the peer-to-peer NetBEUI protocol used in the NetBIOS networking protocol scheme. There was AppleTalk. Apple had their own proprietary protocol. The list goes on. Of course, we've now standardized across the world on the TCP/IP protocol stack, and I think that's a good thing. In terms of Windows 7 TCP/IP configuration, chances are you're going to want all of your desktop workstations, with only small exception, to be using Dynamic Host Configuration Protocol auto configuration. On the other hand, you may have need in your environment to give a Windows 7 box a static IP address that's hand-coded and non-changeable. Your mileage may vary. In terms of the minimum possible configuration of Windows TCP/IP, or should I say just TCP/IP in general, you've got two numbers, the IP address and the subnet mask. Now again, it's beyond our scope to go detail into the mechanics of TCP/IP, but suffice it to say, an IP address is either a 32-bit or a 128-bit number, depending upon whether we're using IPv4 or IPv6, that's meant to denote two things. One, the subnet on which that host resides, and the specific host identifier that maps to that interface specifically. Now, how does the local machine and other machines with which the local host is communicating going to know the difference between the subnet part of that number and the host address part of that number? For instance, if your IP address is 192.168.1.1, how do these computers understand which part of the address refers to the subnet or network segment, and what part of the address deals with the host ID? Well, that's the subnet mask, which, as I'm sure you know, is a collection of ones and zeros that's meant to draw that split line. So you're seeing in this simple example what's called a Class C subnet mask that involves 24 ones, that's the 255s when we convert the binary to decimal, that effectively masks or separates, in this case, the first 3 octets, octet meaning a collection of 8 bits, from the final octet. So in this case, the .1 is the host identifier mapped to that computer's network interface. The first 24 bits denotes the local subnet on which that host resides. Now, without a default gateway address, this host is not going to be able to communicate with any hosts outside of the 192.168.1 subnetwork. We'll talk about default gateways in the next couple of nuggets. All right, so we know so far that you've got 2 methods of assigning IP addresses, either automatically through DHCP. By the way, Windows Server 2008 supports DHCP v6 if you're using the latest and greatest version of the Internet Protocol, or we can do static assignment. Something that you may not be aware of that you should for your exam is this Link Layer Topology Discovery Protocol, or LLTD. The basic mechanics or reasons for existence for this protocol, which is part of the Microsoft Rally subset of technologies, is to populate the network map in the Network and Sharing Center control panel. And more on that later, actually. Now, by default, Windows 7, Windows Server 2008 will show up in that network map, as will Windows Vista, because all of them have the LLTD responder on board by default in their TCP/IP stacks. If you want to incorporate Windows XP into the network map, you'll need to download the free LLTP responder from Microsoft.com. Now, officially, and this is kind of weird, Windows Server 2003 does not have an LLTD responder, but there are various hacks and workarounds available on the internet that are not supported by Microsoft but will work if you do use the network map and you want your down-level Windows Server 2003 machines to show up. Now then, as far as TCP/IP basic troubleshooting is concerned, what does it mean if a user can't connect in the local LAN and you verify their IP address is starting with 169.254? What that should tell you immediately is that this machine is A, configured for automatic IP address assignment by DHCP, and B, that client computer, for whatever reason, is unable to obtain an IP lease from your DHCP server. IP addresses, they're actually Class B addresses that begin with 169.254, are part of what Microsoft calls Automatic Private IP Addressing, or a PIPA. This was introduced in Windows 98 2nd edition, been around for a while in other words, and was originally designed or developed by Microsoft as a, quote, easy way for home network folks who have no conception of TCP/IP to bring up a home network. Because the bottom line is, if a computer is a DHCP client, which in Windows, you know that is the default configuration, and the machine is unable to obtain a real live lease from a DHCP server, it will auto-generate or auto-assign itself a 169.254 address. And because the x.y here represents 16 bits, or over 65,000 possible addresses, the likelihood of having a collision between 2 computers on your home network is pretty small. What Microsoft didn't foresee is the advent of the home router, which, as you probably know, includes their own DHCP server. So functionally nowadays, as DSTs, we look at 169.254 as a troubleshooting signal as opposed to an easy way to do network connectivity. Another thing you want to do really low level to make sure the TCP/IP stack is configured correctly is to do what's called loopback testing. Once you have a network interface up on a computer and you have TCP/IP installed, you can ping either ::1, that's the loopback in IPv6, or you can do the IPv4 address 127.0.0.1. 127 is a reserved Class A block, and this specific address is always mapped to the local host. Of course, you can't connect to someone else's 127 zip1 under normal circumstances. And if you can get responses back to your 4 ping packets on this address, then you can be reasonably assured that the TCP/IP stack is at least functional on that machine. No guarantees you'll be able to connect to other hosts on the local subnet, much less remote subnets, but at least you have the stack working correctly on the local machine. For the 70-685 exam, as well as in your professional lives as enterprise desktop support techs, it's crucial that you know at the least the following collection of standard TCP/IP testing and config tools. Now, some of these, like ping and ARP, are just part of the RFC, or request for comments, standards compliant TCP/IP stack that you'll find in other OS platforms as well. Others are specific to Microsoft, like ipconfig. If you've used Linux, you're probably familiar with the ifconfig, or the interface config. Here, this is a little bit different. ipconfig in Windows has less functionality than ifconfig in Linux. Anyway, I get ahead of myself. Probably the most popular troubleshooting tool in TCP/IP, and these are all command line tools incidentally, is the ping. Now, in terms of what ping means, you'll find that some folks say that ping stands for Packet Internet Groper, and then I read recently that the person who developed this tool originally in 1982, I believe, as part of the BSD Unix distribution, that author actually had no Packet Internet Groper in his mind. His thought was, with sonar and submarines, you hear that ping ping because the sonar is meant to cut through the water to detect the presence of other ships. That was the idea there. And actually, it's the same idea in computing. Ping relies upon the Internet Control Message Protocol, or ICMP, and in Windows will send 4 specifically formatted ICMP messages. In other words, what are called echo request messages. You can send those to a host name or an IP address, depending upon what you're doing for name resolution. The idea is if the other host is not blocking ping, which more and more is the case with, for instance, Windows Firewall on Windows machines, or certainly if you're trying to ping a web server, like if you try to ping Microsoft.com, even though the web servers there are certainly online, their routers are configured to block incoming ping requests, so you won't get any responses. Therefore, ping is probably not as useful today as it once was to test connectivity, but at least on your local network, as long as you have control of your machines and you're allowing ICMP traffic, in particular incoming pings, it's a nice way to check the status, or initial up status, of a machine. Now, we can also look at ARP. ARP stands for Address Resolution Protocol, and it's used all the time on your computer and you don't even know it. What ARP does is it requests and fetches the MAC address of a target host. In other words, and this happens transparently. So for instance, if you ping 192.168.1.1, ARP is automatically invoked and will contact that remote host and literally ask. If you look at network traces, you can see the message format uses stuff like, what is your MAC address? I mean, it's kind of funny the way that those packets are coded. ARP fetches the hardware address of that remote host, and that's crucial because you need to have each machine in a TCP/IP exchange needs to have the other's hardware address in order for data to be transferred between them. It's not just what's called the logical address, that's the layer 3 or IP address. We're also dealing with the layer 2 MAC address in order for that communication to really lock in. There's another tool related to ARP called GetMac, which is a way for you as an administrator to kind of control ARP at a little greater level. You'll see that in Windows we can use ARP to view the current cache of MAC addresses we have and flush that cache. We can use GetMac to actually proactively request MAC addresses from local or remote hosts. ipconfig is really a Swiss Army knife utility. You're probably familiar with ipconfig/all that'll give you the complete configuration data on all your network interfaces. But you can also do things like release and renew your DHCP lease and flush your DNS resolver cache. Network Shell, or NetSH, again, this is a tremendous tool, very much a Swiss Army knife, and a nice advantage is that it's eminently scriptable with shell scripting or Windows PowerShell or VB scripting, and you can use this to configure, not just view data, but configure most or all aspects of your TCP/IP setup. In particular, NetShell contains different contexts. For instance, you can shift your context to Windows Firewall and actually modify Windows Firewall rules from the command line. Very cool. Netstat is nice, especially if you're suspecting rogue processes, malware infestations, or just diagnosing slowdowns on a system. This will give you a run of current TCP connections to that host. So if you see some wonky IP addresses that are connected to off service numbers on a computer, you can start going down the road of, is this computer compromised somehow? DNS-CMD is a Windows utility. Look at this as a command line interface for the DNS management console. Again, one thing that kind of runs through all these command line utilities is the fact they're eminently scriptable. Of course, it's a lot harder to script a GUI tool. You can easily script to perform automated tasks using command line interfaces. And then we have NetDiag, which from the name, you can tell that this is a diagnostic tool. It will allow you to test more robustly than just pinging the local host address, your TCP/IP stack. In this demonstration, I'm going to reveal to you or review with you, depending upon your background, the basics of Windows 7 TCP/IP client configuration, and we'll also integrate testing connectivity using some of those command line tools as well as the graphical user interface, in particular the Network Diagnostics Framework or NDF. Let's step into Windows 7 and get to work. Alrighty then, let's do some TCP/IP configuration and basic troubleshooting. We're on a Windows 7 Ultimate Edition PC named WinNugget, as you know, domain member. I'm logged on using a domain administrator account called Trainer. Now to begin with, I would recommend on your administrative workstation, and you might want to consider enforcing this for all of your desktop PCs, exposing the network option off the Start menu. It's hidden by default. We right-click the taskbar, go to Properties, go to Start menu, go to Customize. Here's where you can bring out some of that stuff if you aren't already aware of that. There's the network option right there. Once the network option is here, we have a nice, convenient means for accessing the Network and Sharing Center. Of course, we can always type in the search box, Network and Sharing Center, to get to it that way. Different strokes for different folks. I'm used to right-clicking the network option and selecting Properties from the shortcut menu. Now, we're going to talk about network locations in a future nugget, so I'm not going to get into that now. What I want to draw your attention to, first of all, is you notice that up on the top we have a brief representation of the network map that shows WinNugget, the local machine, NuggetLab.com because we're in a domain network location environment, and this machine currently is not able to access the internet. If we were, then this globe would be lit up in full color, and of course this red X would be gone. Now we're going to look at network troubleshooting in just a minute. You notice if I hover over the X, the tooltip says click to troubleshoot problems. We'll talk about the troubleshooter in just a second. First though, you'll notice on the task pane, we have change adapter settings. This is where we can get into our network and internet network connections control panel item. Now if we double left click the connection, you see something that's been around all the way since Windows XP. It gives us the connectivity for IPv4 and v6, whether we're enabled or disabled, how long we've been up, what our link speed is, packets sent and received. That can be especially helpful in terms of troubleshooting connectivity. Now again, there's a diagnose button here to bring up the network diagnostics, or we can use the UAC shield protected button properties to get into the properties. Alternatively, we can right click the connection to disable, diagnose yet again, and now we'll go into properties to bring up the specific interface parameters. Again, this is very similar dialog. It's been around in Windows for a long time. You should be pretty familiar with it at this point. I want to draw your attention to a couple pieces here. One, you'll notice in Windows 7 we have a native TCP/IP v6 protocol stack loaded, and by default you have what's called stateless auto configuration, where the machine will pick up a dynamic, it'll generate itself, or in conjunction with its default gateway, a unique IPv6 address. In this Nugget series, we're primarily concerned with TCP/IP IP version 4, your traditional 32-bit address space. If you do want to use the network map, you'll want to make sure that you have the driver and the responder enabled. There it is right there. Link layer, topology, discovery, mapper, IO driver, and then the responder. All right, good. To get into the TCP/IP v4 properties, we can double left click. You see that I've set a static IP address and pointed this machine to a DNS server. More on this stuff later. Of course, the default is to obtain an IP address and a DNS service automatically through Dynamic Host Configuration Protocol, or DHCP. Let's step back to the Network and Sharing Center, and I just want to show you, if you want to see a full map of, in this case, our domain, we can click the See Full Map button. And you see in this case we have our machine, WinNugget, and if we hover over it, you can get lots of cool information, including the IPv4 address, the stateless auto-configured IPv6 address. It's called a link local address. You can tell you're dealing with an auto-generated link local IPv6 address if that address starts with FE80, and you also see MAC address. If I hover over our domain controller DCNugget, again, we can see IPv4, IPv6, and the MAC address. These are live links, and of course we have switch connectivity as well. Let's come back here. Now, normally in a domain environment, mapping is disabled. So even though DCNugget, my domain controller, has the LLTP installed, I had to actually go into group policy. Let me quickly show you that by going into Administrative Tools, Group Policy Management. The reason why I'm able to connect to Active Directory group policy from WinNugget is because I have the Windows 7 Remote Server Administration Tools, or RSAT, installed. We covered how to install those in the previous Nugget. I edited in the background our default domain policy. Let me show you where your network map options are stored in group policy. They're under Computer Configuration, Policies, Administrative Templates, Network, Link Layer, Topology Discovery. And you can turn on the mapper and turn on the responder, hit your client computers, hit your server computers with this, and that'll ensure that your network map is populated. As far as built-in troubleshooting, the network diagnostic framework stuff, if you type troubleshooter in the start box, you see we get a control panel link called Find and Fix Problems. This brings up the troubleshooting control panel, and specifically, I want us to focus on the network and internet area. But the reason why I brought us here to this base control panel of troubleshooting is because this is a line of defense for you as a desktop support technician for running automated remediation and troubleshooting of many aspects of your users' systems. You'll notice that we have display troubleshooting, program troubleshooting, hardware and sound troubleshooting, system and security troubleshooting, and then what we're going to look at now, network and internet. Now in the network and internet troubleshooting category, you have subsets here. Are you dealing with shared folder troubleshooting, network adapter troubleshooting, etc.? I'm going to choose network adapter here, and this fires open the built-in troubleshooter for this. Now troubleshooters have been around for a while, since Windows XP. However, this functionality, especially with the network diagnostics framework, has ramped up considerably in Windows Vista and Windows 7, because instead of just presenting the user or the DST with a wizard asking you questions, can you do this, can you do this, have you tried this, have you tried that, you'll notice that the troubleshooter actually has built-in a detection routine to work through your problems. Now, of course, troubleshooting couldn't identify a problem because my network adapter is working fine. So know that this exists. As I already showed you, another interface into the network diagnostic framework we can get to from, again, the Network and Sharing Center. Where you have a red X, we can click that red X to immediately launch Windows Diagnostics focused on that element. In this case, we're looking at issues with web compatibility or web connectivity. And then the adapter itself, we can go right to the heart of the matter by right-clicking and selecting Diagnose. Next, let's have a look at TCP/IP troubleshooting from the command line. I've opened up an elevated command prompt here on WinNugget. Let me clear the screen. And one thing, actually, even before we use ping, let's use ipconfig and see what we've got going on. Running ipconfig with no other parameters gives you basic interface metadata. Stuff that you basically can see if you double left click the connection in the graphical user interface. Now, if we run ipconfig /?, you can see all of the options. ipconfig all is full config information. You notice you have release and renew. You use those to manually release and manually renew an address lease from a DHCP server. We have register DNS, display DNS, flush DNS. Those are pretty cool. Those are obviously all dealing with DNS name resolution. If, for instance, you have a stale entry in your DNS resolver cache that's taking you to an invalid or incorrect destination on the local network or the internet, you can run ipconfig. Well, first let me do display DNS to show what's in the cache. And because all I've been connecting to is DCNugget, you'll notice that those are the only entries that are in here. We have some LDAP Active Directory related DNS records that are cached. inverse lookup records, and then finally we get some host record information. There's dcnugget.nuggetlab.com. As you're browsing the internet or other network resources on the local network, your DNS resolver cache will get more and more full. Of course, it's the server itself, the DNS server, that's responsible for timing out how long clients can cache this information. If I do a flush DNS, which is a good thing to do if you're troubleshooting name resolution problems, then I'm going to use the up arrow to display my cache again. We still have some entries for DC Nugget, which makes sense because we're in a domain environment. Those aren't going away, it looks like. Let me one more time bring up the ipconfig question mark. The only things left that we can do deal with DHCP classes. In a nutshell, DHCP class IDs are a very, very granular way for DHCP to work. I don't know if you're familiar with how DHCP server works in Windows. Normally you have a scope attached to an IP subnet. You can get more granular and display, or should I say register, certain clients that meet certain criteria and attach those to different scopes using a discrete class ID. Well, anyway, ipconfig enables you to do that client-side setup with that. Good and good. Now, how about ping? I mentioned that you can ping and should ping the local host address to verify IPv6 and or IPv4 connectivity, just that you have the stack correctly installed and nothing's corrupted. The IPv6 loopback address is ::1. As you probably know, the 127.0.0.1 loopback address. And as long as we're getting replies, we know that the stack is configured okay locally. Of course, the next thing to do is to ping your own IP address. Remember, the IP address is a logical address. Logical because it's eminently changeable. If the local host and the local logical IP work, it makes sense in our connectivity to then ping another host or maybe our default gateway on our local subnet. So far, everything's rosy, isn't it? Now, I don't have connectivity outside the local network, but I would want to ping a host on the other side of my router if I did. Now, ping's pretty cool. Let me clear the screen and run a ping with /?. There's some nice ways to extend this command. You'll note that by default, ping sends 4 ICMP echo request messages. If we want to send more or greater number or a fewer number of those, we can use the N switch, I'll say 10, and send those in. Now you can stop the running of any command from a command line using the break sequence Control-C, which I'll do right now. That'll break us out of that. Another thing we can do is ping A, and what'll happen there is that ping will attempt to resolve the host name that's associated with that IP address. That can also be helpful for you. Because I do have name resolution here, DNS actually, I can ping dcnugget.nuggetlab.com and use DNS to resolve that name. So as you see, ping again is a very multifunctional tool that we can use to verify connectivity with a host. Now I had to go into the configuration on the server and make sure that I'm allowing incoming ICMP ping. Normally pings would be disabled, remember that. And I don't think I gave you the main reason for that if you don't already know. The reason why incoming pings are a security problem is the denial of service aspect, and even more so, the distributed denial of service or DDoS possibilities if you have hundreds, thousands, or perhaps tens of thousands of hosts all sending pings simultaneously to the same machine. It's certainly going to bring it offline. Let's clear our screen and continue. A command that I didn't mention in the whiteboard portion of the course that you might want to be aware of is pathping. And we're going to talk about the traceroute command in an upcoming nugget. Pathping is cool because it's a combination of the ping and the traceroute utilities. Now, it's not going to be very dramatic here because we have just no routing interfaces between our local machine and DC Nugget. But what you get basically is a stepwise traceroute combination with the ping to that remote host, which can be helpful in terms of mapping out the specific path, hence the name pathping, that those ICMP packets take in between the local machine on which you're working and that target workstation. So you'll notice it does the traceroute, and then it gives you specific metadata in terms of lost and so on. The RTT is important for determining latency and where perhaps a slowdown occurs between the two machines. Finally, let's look at Network Shell, or NetSH. As I mentioned, this is an extremely robust tool. When you use NetSH, you typically provide what's called a context. In other words, are you using NetSH to configure the advanced firewall, branch cache, DNS, DHCP, IP addressing, remote access? And once you get into a context, for instance, if I do NetSH ADV firewall for the advanced firewall utility, we can look at help regarding that context. And you see we can monitor statistics, we can import policies, we can configure the firewall, we can export policies, etc. So I just want you to be aware that NetSH is a tool that you certainly want to spend some time learning more about. For your 7685 exam, just know that it's a Swiss Army knife that enables you to manage practically any aspect of the TCP/IP stack and related services on a Windows 7, Windows Server machine, whichever. Identifying Network Connectivity Issues, Part 1 of 2 review. In this nugget, we spent quite a bit of time on the mechanics of TCP/IP configuration and diagnostics in Windows 7. We first looked from a holistic level, strategies for approaching network issues. In particular, determining the issue scope. Is the scope just constrained to a single workstation, multiple workstations? And then we looked at that split-half troubleshooting model. The bulk of the nugget dealt with TCP/IP client-side configuration in Windows 7. I hope you're very familiar with how this works now, because believe me, in your professional lives supporting Windows 7, you'll be using these tools every day, I can essentially guarantee you. Bookended with the configuration, as you remember, we looked at testing network connectivity using GUI and command line tools. I hope that this has been informative for you, and I'd like to thank you for viewing.